video you should be listening to. It's example 3. And this one looks like a doozy, but we just got to start looking at it and figure out what do we know and what can we do. So find A and B so that the normal line of y equals a root x plus b has a slope of 2 at the point P, 9, and 1. So when we see normal, we got to remember that's the negative reciprocal of the slope. So the slope at any given point is the derivative. So the first thing we need to do is actually figure out, well, how do we take the derivative of y equals a times the root of x plus b? Well, first thing I'd like to do is change that root to an exponent. So let's just rewrite our equation down. And let's just take the derivative of this. We know a and b are constants, so this isn't a big deal. So we have y prime is equal to, I bring that 1/2 down and then multiply by the a. So I'm going to end up with a over 2 x to the negative 1/2. And then the derivative of any constant is 0. So I don't have to worry about the b at this point, because the derivative of any constant is 0. So let's kind of write this a little bit nicer. So that's going to be equal to a over 2 root x. So we know y prime is equal to a over 2 root x. So at that value, 9 and 1, so at that point, sorry, we know the normal line has a slope of 2. So the normal, or the slope of the normal, is equal to 2, then the slope of the tangent is going to be equal to the negative reciprocal. So we know that y prime at 9 of that function has to equal to negative 1/2. Okay, the b is going to come, and we've got to figure that out in a little bit. But right now, we know that y prime at 9, so wherever we see an x, that has to equal to negative 1/2. So y prime at 9 is equal to, well, a, I don't know what I'm subbing that in for, 2 root 9, and we know that has to equal to negative 1/2. So it's going to be a over 2 times the root of 9. So root of 9 is 3, 3 times 2 is 6. So a over 6 equals negative 1/2. So we can see by looking at that, use up a little bit of space here, we can cross multiply and divide any way you think about that, or you can just see that if we have a value of a being negative 3, we'll actually get there. So I'm really, really close now. I have my a, I just need to figure out my b. All right, so we have our a, we need our b, and we have to remember that we know that the point P, 9, 1, lies on the original equation. So a tangent point or a normal goes through that point. So 9, 1 is our point of tangency, and it's the point at which our normal line goes through. So I can just go back to my original equation now. I have my y and my x, I have my a, I just need to find my b. So my original equation was y equals a root x plus b. We know a is equal to -3. We know x is equal to 9. And we know y is equal to 1. So how did I get that again? I'm just grabbing that original stuff in my equation. X is 9, y is 1. That comes from my points. And then I found my a. So we just sub everything in, we're going to be able to find our b. So we will have 1 equals -3 root 9 plus b. So root of 9 is 3. 3 times -3 is -9. So 1 equals -9 plus b, where we have b equals 10. So we now know that if a is -3 and b is 10, we have met all the conditions. Okay, oops, I'm going to stop here before we look at the next one in case something goes crazy.